So when most people think of the word matrix or matrices, they usually think of the insanely popular movie. And while matrices may have been used within that movie, the actual mathematical concept goes a lot deeper. So the actual definition of a matrix is a collection of numbers arranged into a fixed number of rows and columns. And most matrices are written out like these three, and they can be pretty much anything, but they are defined by the number of rows and columns. So like this one, for example, has 3 rows and 2 columns. So it's defined as a 3 by 2 matrix. You would have matrices like these, which is just 1 by 1 because it has 1 row and 1 column. Then and as another example, it's 2 rows, 4 columns, so it would be defined as a 2 by 4. There are also special matrices, such as the identity matrix, which is basically equivalent to 1 in the terms of real numbers. And it's written, it can be as big or as small as you would like, but it has to be a square, so there has to be the same number of rows and the same number of columns. And it is useful, it's written as the ones are in the diagonal spot and zeros fill everything else, and it is useful for inverses, which are used in dividing. Okay, for the basics, these are the basic operations you can do with multiple matrices. So for addition, it's pretty simple. You just take numbers in the exact same spot of the equivalent matrices. They have to be the exact same size, otherwise it would not work, and you just perform addition on them. So it would be 3 plus 4 equals 7, and you just carry on that way for each of the numbers, each of the entries into the matrix. For subtracting, basically the same principle with subtracting. So you take the ones in the equivalent positions, subtract them, so 3 minus 4 equals -1, and again, these all have to be the same size, they have to have the same number of entries. So then you can use a negative matrix. Basically the exact same principle. The negative applies to each entry in the matrix, so 2 becomes -2, -4 becomes 4, etc. Then you can do transposing, which is basically a really complicated way of saying flip them. So the rows become the columns, and the columns become the rows, so the row of 6, 4, 24 becomes the column of 6, 4, 24, and it basically just looks like that. And then notation, so the matrix is usually notated as an uppercase A, or an uppercase letter, it can be any letter, and the entries within the matrix are the lowercase letter defined by the row in the column. So this one right here will be lowercase a sub 1, 1, because it is in the first row in the first column. Then this one right here, lowercase a sub 2, 1, because it is in the second row in the first column. So when it comes to multiplying, when you multiply by a constant, it's still pretty simple. You still just apply the constant to each one of the entries. And so 2 times 4 times 0 times 1 times -9, and you get this, 802, -18. But when it comes to multiplying by another matrix is when it gets a little more complicated. So essentially all you're doing is eventually multiplying all the rows by all the columns. So you multiply, you start with the first row and the first column, 1 times 7, 2 times 9, 3 times 11, and add all of those together to equal 58. And that goes into the first entry in the new matrix. And then essentially you move on to multiplying the entries in the first row, again, second column, which is right here, the second row in the first column again, right here, and the second row in the second column, right here. And those come out to 64, 142, and 154, which you put into your matrix, and that's what you get as your final answer as A, B, and AB. And in multiplication, order does matter, because A times B will get you this, but B times A will get you a completely different calculations. Okay, so dividing is where it gets a lot more complicated, because with matrices you cannot technically divide, so instead you multiply by the inverse. So it would be A divided by B is equal to A times 1 over B, which is the reciprocal, same thing, is equal to A times B, the inverse of B, notated by a -1. So first you need to know how to calculate the inverse. So with an example of 4, 7, 2, 6 in the positions of A, B, C, and D, you would swap A and D and add negatives to C and B and multiply by 1 over A times D minus C times B, which is, this is what it's written out as, which is equivalent to 1 over 10. And then you go back to multiplying by a constant, and you multiply the constant to each of these entries, which gets 0.6, -0.7, -0.2, and 0.4. Once you have that, you can apply that to your dividing by matrices. So with the matrix of 1, 2, 3, 4 divided by the matrix of 5, 6, 7, 9, the inverse of 5, 6, 7, 9, you basically do all of this, which comes out to 3, -2, -2.3 reoccurring, and 1.6 reoccurring. Then you move on to, you go back to your multiplying by another matrix up here, and you multiply 1, 2, 3, 4 times 3, -2, -2.3 recurring, 1.6 recurring, which, having done all the calculations, comes out to -1.6 reoccurring, 1.3 reoccurring, -0.3 reoccurring, and 0.6 reoccurring.
Some real-world applications for matrices include physics, robotics, programming, and geology. For physics, they're used in quantum mechanics. For robotics, they are the basis for the movement of the robot. For programming, they are used for coding and encrypting messages like spies. And for geology, they're used for seismic surveys and statistics. We chose this topic because after doing our initial research, we decided that it was really cool and it had a lot of real-world applications that we could later learn more about. We learned the basics of everything, and we thought it would initially be easy, which is also another reason why we chose it, but it's very complex and difficult, especially when getting into things like dividing.